FLAC is an audio coding format for lossless compression of digital audio, and is also the name of the reference codec implementation. Digital audio compressed by FLAC's algorithm can typically be reduced to 50–60% of its original size and decompressed to an identical copy of the original audio data. FLAC is an open format with royalty-free licensing and a reference implementation which is free software. FLAC has support for metadata tagging, album cover art, and fast seeking. Though FLAC cannot store floating-point data, and playback support in portable audio devices and dedicated audio systems is limited compared to lossy formats such as MP3 or uncompressed PCM, FLAC is supported by more hardware devices than competing lossless compressed formats such as WAV-PAC. History: development was started in 2000 by Josh Coulson. The bitstream format was frozen when FLAC entered beta stage with the release of version 0.5 of the reference implementation on January 15, 2001. Version 1.0 was released on July 20, 2001. On January 29, 2003, the Kshift.org Foundation and the FLAC project announced the incorporation of FLAC under the Kshift.org banner. Kshift.org is behind other free compression formats such as 4Bs, Theora and Speaks. Version 1.3.0 was released on May 26, 2013. Development was moved to the Kshift.org Git repository. Composition: the FLAC project consists of the stream formats, a simple container format for the stream, also called FLAC, ʻflæk, a library of reference encoders and decoders, and a metadata interface, ʻflæk++, an object wrapper around ʻflæk, ʻflæk, a command line program based on ʻflæk to encode and decode FLAC streams, ʻflæk, a command line metadata editor for FLAC files and for applying replay gain, input plugins for various music players, with Kshift.org incorporation, the OGG container format, suitable for streaming. The specification of the stream format can be implemented by anyone without prior permission, and neither the FLAC format nor any of the implemented encoding/decoding methods are covered by any patent. The reference implementation is free software. The source code for ʻflæk and ʻflæk++ is available under the BSD license, and the sources for FLAC, ʻflæk, and the plugins are available under the GNU General Public License. In its stated goals, the FLAC project encourages its developers not to implement copy prevention features of any kind. Design: audio sources encoded to FLAC are typically reduced to 50–60% of their original size. FLAC supports only fixed-point samples, not floating-point. It can handle any PCM bit resolution from 4 to 32 bits per sample, any sampling rate from 1 Hz to 655,350 Hz in 1 Hz increments, and any number of channels from 1 to 8. Channels can be grouped in cases, for example stereo and 5.1 channel surround, to take advantage of intercanal correlations to increase compression. FLAC uses CRC checksums for identifying corrupted frames when used in a streaming protocol, and also has a complete MD5 hash of the raw PCM audio stored in its stream info metadata header. FLAC allows for a rise parameter between 0 and 16. FLAC supports replay gain. FLAC uses linear prediction to convert the audio samples to a series of small, uncorrelated numbers, which are stored efficiently using Golomb-Rice coding. It also uses run-length encoding for blocks of identical samples, such as silent passages. For tagging, FLAC uses the same system as 4B's comments. The ʻflæk API is organized into streams, seekable streams, and files. Most FLAC applications will generally restrict themselves to encoding-decoding using ʻflæk at the file-level interface. Compression levels: ʻflæk uses a compression level parameter that varies from 0 to 8. The compressed files are always perfect lossless representations of the original data. Although the compression process involves a trade-off between speed and size, the decoding process is always quite fast, and not very dependent on the level of compression. Comparison to other formats: FLAC is specifically designed for efficient packing of audio data, unlike general-purpose lossless algorithms such as ʻflæk, which is used in ZIP and gzip. While ZIP may reduce the size of a CD-quality audio file by 10–20%, FLAC is able to reduce the size of audio data by 40–50% by taking advantage of the characteristics of audio. The technical strengths of FLAC compared to other lossless formats lie in its ability to be streamed and decoded quickly, independently of compression level. In a comparison of compressed audio formats, FFmpeg's FLAC implementation was noted to have the fastest and most efficient embedded decoder of any modern lossless audio format. Since FLAC is a lossless scheme, it is suitable as an archive format for owners of CDs and other media who wish to preserve their audio collections. If the original media is lost, damaged, or worn out, an FLAC copy of the audio tracks ensures that an exact duplicate of the original data can be recovered at any time. An exact restoration from a lossy archive of the same data is impossible. FLAC being lossless means it is highly suitable for transcode, for example to MP3, without the normally associated transcoding quality loss. A Q file can optionally be created when ripping a CD. If a CD is read and ripped perfectly to FLAC files, the Q file allows later burning of an audio CD that is identical in audio data to the original CD, including track order, pre-gaps, and CD text. However, additional data present on some audio CDs such as lyrics and CD+G graphics are beyond the scope of a Q file and most ripping software, and that data will not be archived. Adoption and implementations. The reference implementation of FLAC is implemented as the ʻflæk core encoder and decoder library, with the main distributable program Flac being the reference implementation of the ʻflæk API. This codec API is also available in C++ as ʻflæk++. The reference implementation of FLAC compiles on many platforms, including most Unix and Unix-like, Microsoft Windows, BOS, and OS/2 operating systems. There are build systems for AutoCone Automake, MSVC, WatsumC, and Xcode. There is currently no multi-core support in ʻflæk. Though FLAC playback support in portable audio devices and dedicated audio systems is limited compared to formats such as MP3 or uncompressed PCM, FLAC is supported by more hardware devices than competing lossless compressed formats such as WAV pack. FLAC support is included by default in Android and Jolla devices. In 2014, several aftermarket mobile electronics companies have introduced multimedia solutions that include support for FLAC. These include the NEX series from Pioneer Electronics and the VX404 and NX404 from Clarion. The European Broadcasting Union has adopted the FLAC format for the distribution of high-quality audio over its Euroradio network. The Android operating system has supported native FLAC playback since version 3.1. The Pono Music Player and Music Service and the Qobuz Music Streaming Service both use the FLAC format. Since January 2014, GOG.com offers video game soundtracks in FLAC format as bonus. See also: Comparison of audio formats, Apple Lossless, References. External links, FLAC a Euro-free lossless audio codec official website, Lossless Audio Formats Comparison, measuring FLAC against 5 other lossless audio formats, XMA and a phone finder, all phones and tablets with FLAC support, Java library.